Hello everyone, myself Vignesh Anand. In this video, we are going to see about the circuit breaker, basics of your circuit breaker diagrams and the types. First of all, circuit breaker is a device which breaks the faulty circuit to protect from the damage caused by short circuit fault current, overload current, earth fault current in the circuit. And after clearing the fault, the load can be easily linked to the circuit by closing the circuit breaker manually or automatically from the local or remote end. In the earlier video, I have explained each circuit breakers. Now, commonly, what is circuit breaker and the circuit breaker parts. Coming up to the portion, the circuit breaker consists of a fixed contacts, sliding contacts, and moving contacts. So the moving contacts moves into the sliding contact, and a handle is attached to the moving contact, which can be manually operated or it can be operated automatically with the help of a mechanism which has a trip coil energized by the secondary current of the current transformer. So normally the circuit breaker, in the sense, it consists of a fixed and moving contacts. So the sliding contacts is placed with the moving contact, and as I said, the supply is given and the CT is connected to your relays, and the manual handles are connected to your relay portions. So under a normal condition, the current in the secondary coil of your CT is not sufficient to energize the tripping coil fully. At a fault condition, the abnormally high value of current flows in the primary of the CT, resulting a high current, which means high secondary current will flows in your circuit to energize the tripping coils. And the tripping coil is set to release the handle mechanisms which operates the circuit breaker, and the circuit breaker disconnects the faulty portion from your healthy portion. So this is your opening of your breaker. Normally the fixed moving contacts get moved because of this CT, which senses the fault current and gives the initiation to the trip coil. So the opening time of your breaker, in the sense, the time interval from the energization of your trip coil to the instance of your contacts separation. Then arcing time, in the sense, while at the time of opening the arcs may produce, so the during at the time of separation the arcs may produce, and that arcs is called as a arcing time. So break time, in the sense, the total amount of your opening and the arcing time is commonly known as the total break time. For further analysis, this opening, arcing, and total break times are used in your maintenance of your breaker. Then types of or classification of your circuit breaker. Normally, it is classified in various types as a interrupting medium, service, operation, contacts, actions, method of control, tank constructions, mounting. So uh, each has a varieties of tabulations. In here I'm just simply explaining the interrupting medium, air blast, oil, vacuum, SF6. So these are all the mediums which are used for your breaker operations. And services, in the sense, indoor and outdoor. If the SF6 breakers are kept in an outdoor station, indoor means vacuum circuit breakers. These are all the common classification of your circuit breakers. You can just uh, pause the video and check once. Next, coming up to the types of circuit breakers classified according to their medium. Here the MCB, miniature circuit breaker, used up to a voltage range of 400 to 600. Then air brake circuit breaker, ABCB, 400 volt to 11 kV. Then minimum oil circuit breaker, 3.3 to 220 kV, vacuum circuit breaker 3.3 kV to 33 kV. Nowadays this vacuum circuit breaker are used up to 72 kVs also. Then SF6 breaker is normally used in your indoor and outdoor side. Uh, it is up to a 3.3 kV to ultra high voltage of 765 kV. Then air blast circuit breaker 66 to 110 kV. Next, coming up to the portion of circuit breaker diagram explanation. Now we are going to see about the basics of your circuit breaker diagrams. In here, normally in circuit breaker we will use a DC supply, because in case of any emergency or anything, suppose all the auxiliaries get cut off, means the DC is normally produced in our substation by through a chargers, which means DCDB chargers, which means DC distribution chargers, and those chargers are connected with the batteries. So we have a emergency supply also. So in this case, we are going to use the in maximum substation we will use the DC as the control supply, and here we use two MCBs. One is A and B, positive supply, negative supply, and each MCBs are connected to the further as a fuse, which is your MCBA positive and negative side, MCBB positive and negative side. So further it is moving to your fuses. Each positive negative are separated by a separate fuses, and your A supply is going to your tripping circuit, and B supply going to your closing circuit. So this is your very basics of your circuit breaker diagrams. Further, it will in practically it will be having a more number of pages by additionally adding the pole discrepancies, and also the spring charges status, spring charges operations, AC, and also the mechanism and marshalling boxes separate, because in a three-phase circuit breaker each phases will have a separate mechanism box, and all those mechanism box will be connected to your common marshalling boxes. So the diagram may varies according to your placement, or according to your variation in your circuit breakers, but the closing and the tripping circuit maximum it will follows these basics ideas only, and further it will be developed by additionally adding some of the auxiliary contacts or auxiliary relays, interlockings, and in tripping side we will add extra trippings, additional trippings, inter trippings like this. Likewise, parallelly we will add the trippings, and in a seriously we will connect any some of the uh, interlocks in between closing and tripping circuits. So coming to the closing circuit, here MCBB is positive side where the TNC switch is connected, and uh, just for your understanding I am saying that the negative supply which goes to your close coil, and then further moves to a up to the uh, local and remote switches, which means uh, for example I am saying now the breaker is in a open condition, so we are going to close those breaker, means the negative supply will get through and fully satisfied up to the local and remote switch. If we put the breaker in local, means it will further move to your TNC switch, which is your closed neutral trip switch. So first for example first I am saying one by one. This is your close neutral and trip switch. Next is your local and remote switch, and the circuit is connected seriously with the low gas relay contacts. For example I am saying that if you are going with a SF6 type of breaker, the low gas relay contacts will be connected in series with the close and trip circuits. Then it will further separated into a two parallel circuit. One is your anti-pumping relay circuit, another one is your main closing coil contact circuits. So here the anti-pumping relay circuit is connected parallel to the closed coil contacts, because once the breaker is get closed, further the positive should not fit to your closing circuits, because the coil get damaged. And also the motor spring charge, the closing and tripping should be initiated by an spring charging of your circuits. So the spring charging for the spring charging also we need some time. So in order to overcome this, we are adding a separate anti-pumping relay circuit in parallel to the closing circuits. Next, breaker auxiliary contact 52 NONC contacts, which means normally open and normally closed contacts, are being connected to your circuits. Uh, just for example, I'm saying that NC contact in the sense normally closed contacts. When the breaker is in open condition, this NC contact will be in a closed condition. When the breaker is closed, this NC contact will be open condition. Vice versa for the NO contacts. If the breaker is in open condition, the NO contacts in open condition. If the breaker is in closed condition, the NO contacts in closed condition. So coming up to the circuit, this NC contacts is connected to their circuit series conditions. Then further moves to your motor switch. Here the motor switch in the sense the spring charging of your breaker takes place, and further after the spring is energized, which means the spring charges in a healthy condition, it will checks once and then it will goes to your close coil. So here the low gas relay, then anti-pumping relay contacts, then breaker NC contacts, then motor switch contacts. All these should get fulfilled, and then only the positive which we are giving at the closed strip coil, which means the closing circuit, the positive get initiated and close, it will reaches the closed coil, and then further the closing of the breaker takes place. Here in the case of remote in the sense, the breaker control relay, which means from the SCADA HMI, the closing operations will be done and the command will be given, and it will check the lockout relay, which means lockout relay in the sense 86 relay. Normally this lockout relay are connected with all the protection relays. So whenever there is any fault happened, the protective relays will operate and it will initiate a lockout relay to get tripped, and that lockout relay, if get tripped, and it will initiate the trip to your circuit breakers also. And further, without a resetting of this lockout relays, we are not able to close the breakers. So we need to check once the lockout relay is in a healthy condition or not. And also this these conditions are connected in seriously for the closing circuits. In a tripping circuit it will be connected in a parallel wise, because the trip in the sense, there may be any chance of fault. So all the tripping should be initiated. It should not be connected in a serious condition, like one should get satisfied, then another one should get satisfied, then only the tripping should be initiated. Likewise we don't need such a conditions for trippings. If any fault is sensed, then directly the tripping should be initiated. So for that we are connecting these breaker control relay trippings and lockout relays in parallel condition for the tripping circuits. So these are all the things in your basics of your circuit breaker closing circuits. Then the fuse, if the fuse is get blasted, or if the MCB tripped, then 87 under voltage relay is connected with that. So with this we can take the MCB status, which means the healthy status can be taken. The DC supply healthy status can be taken by the 27A. Then coming up to the tripping circuit, Here the tripping circuit, in the sense the common DC is your A source, and for this also we are connecting with a uh, under voltage relay. Then this is your low gas relay coil, and the coil, normally this low gas relay coil, it is will be in a drop condition, which means it will not in a energized condition. This coil will be, when it will get energized, in the sense if there is any low level of your gas or oil or anything, the breaker which we are using, according wise we will take this gas relay or oil relay, likewise I'm saying. So once it get initiated, this coil get energized and it will breaks the closing and tripping circuits. Here we have taken the NC contacts for the uh, low gas relay coils, because as I said, NC in the sense normally close. Now the coil is in drop condition, so it will be in a closed condition. Whenever the coil get energized, automatically it will get opened. Next, coming up to the breaker status, which means open and close status. Like in a breaker marshalling box itself, you can see the lights glowing as open and close. For open, just for open you will use a green light, and close you will use a red light. Like for that, how the indications are shown, uh, it's a simple thing. The auxiliary contacts which we are using for the breakers, with that itself you can able to indicate the breaker status. Here the NC, in the sense breaker normally open. Whenever the breaker is in open condition, this NC is in normally it will be in a closed condition, which means the contacts will be in a closed condition. So now the breaker open, in the sense the breaker open indication will glow. Whenever the breaker get closed, this NC will get changed to NO, and the NO will get closed. So the breaker closed condition can be shown by that. Then coming up to the tripping circuits. Here the tripping circuit, same TNC switches and breaker local and remote switches are connected. In here the breaker control relay trip coils, which means the command and the tripping initiation can be given by the breaker control relay tripping coils. Then the lockout relay, which checks the condition of your breaker, and also checks verify with the other protective relays, which means whenever there is any fault is occurring, and the protective relay will operate, and it initiates the trip to the tripping coils of your breaker. And also coming up to the circuit, here the low gas relay is connected in series with the tripping coil circuits. Then the NO contact, NO in the sense normally open. So if the breaker is closed means now I am saying the operating condition, I have closed the breaker, in the sense this NC get opened, and this anti-pumping relay will get opened. This circuit will further move to your this side of your anti-pumping relays. So second time closing, once the breaker is closed, second time closing operation cannot be done. So and then the tripping, we are going to give the tripping initiation. For that we are going to check the negative supply, and the negative supply will first goes to your tripping coil, and then checks the NO contacts. Now the breaker is in close, so it will further changes into a NC, and which means the negative supply will further moves to your low gas relay. Now the gas is in perfect condition, so this coil is in drop. So the negative supply will further moves to your local switch. Now the breaker is in local, so I am further the negative will moves to your up to the end of your TNC switch. Now we can manually trip the breakers. If we are going with remote condition means from the HMI SCADA, the command will be given for a tripping initiation and the tripping is possible. So these are all the very basics of your circuit breaker. Further pre-close and post-close conditions, and then the for the motor switch, which means the spring charging switch conditions, spring charging, how it is happening in your breakers. And for the breaker we need some of the AC supplies for heaters and additional auxiliaries things. And also for the spring charges we need a AC supply or a DC supply likewise for that and all. Additionally, the breaker diagram itself we will see in the practical condition. So this is your very basics of your circuit breaker. Thanks everyone. Hope you understand. I think so. See you in next video. Have a nice day. நன்றி, வணக்கம்.